Hi, welcome to our math class. And today I want us to have a short review of a short but very important topic or an area of a discussion for us. It's something perhaps you've already done, or maybe you're interacting with it for the first time. So, welcome to our session today. And our area of discussion is mass, weight, weight, and so here I put a comma and density, and especially the area of density. This is where I want us to have a discussion. Density is the main concern. So you'll have a short take on mass, weight, then you take some time in density. I hope you have an area or a paper to write or a book. I would prefer a book that you're writing down. You're making some notes so that at the end you can be able to revise on your own. It's also good to know that I'll be having a definition of these terms, helping us to understand. Then after that, we do one or two examples. Then you go to the next one. So make sure you understand the examples clearly so that as I give some task, you'll be able to review and you understand what is happening. So without taking much time, let us begin with the first area, which is mass. And mass, if I am to define what is mass, mass is simply the quantity. It is the quantity of matter in an object, quantity of matter in an object. Mass is the quantity of matter in an object. And the SI unit of measuring mass, the SI unit of mass is kilograms. This is the SI, the unit for measuring mass, and the symbol for that is kg. So mass is the quantity of matter in an object. Then the SI unit of measuring mass is kilograms. We also have some other units of measuring mass. Other units, they are quite a good number, but just to make our work easier, we will just have this common acronym. I hope we have so many, but I'll pick the one that I think is common for us. That Kenya has DAG. Instead of many, we put G there. Kenya has dug instead of many dams containing. We have here containing maji. That these only represent kilograms. We have hectograms. We have decagrams. We have grams here. We have decigrams. We have centigrams, and we have the milligrams. These are among the other units. So this is the SI unit, but these from hectogram, decagram, grams, decigrams, centigrams, milligrams, these are other units of measuring mass. We'll have an example to see how to convert from one unit to another. But simply, when you are converting these units, moving from up, you're heading down. These ones you divide, you multiply. We'll see you're multiplying with what. But when you're moving the opposite direction, which is up, you divide your units. We'll have an example to explain more what is the meaning of that. We also have some other units, and this is ton. Ton is another unit of measuring mass. We also have a megagram. We have a gram, and we also have a microgram. And here simply 1 ton ton, the symbol for that, it is, you can use capital T or small t, or here it's megagram, mg, capital M. To simplify that, let me put them in capital letters. This one is symbol for that is that. We have M, then you have G, that is then this one, the symbol for that is that microgram. It's just good to note that for these three, that 1 ton is the same as 1,000 kilogram. 1 ton is the same as 1,000 kilogram, and which is the same as also a gram. If I say 1 megagram is also the same as 1,000 kilogram. So simply means that ton and megagram, they mean the same thing. Ton is a unit for measuring large weights. We use them to measure very huge weights, and 1 kilogram is the same as 1 billion, 1, 2, 3, 4, 5, 6, 7, 8, 9 microgram. So it's good to know that 1 ton is the same as 1,000 kilogram, and 1 megagram is also the same as 1,000 kilograms, and 1 kilogram is the same as 1 billion, or a number with 9 zeros, microgram. We can have some quick examples on how to conversion of units. So we'll just pick a few examples here. We will see, and I have quite a number of questions here. If I pick just any of them here, for example, you look at this one, they are telling us express each of the following masses in a kilogram. So they want us to convert into kilogram. So I can pick any of these. Let me pick like 435 decigrams, and maybe 800 grams. So I'll pick, they want us to convert into kilograms. The first one, it is 435 decigrams, and the other one is 800 grams. Now, when you are here, we want to convert decigrams into kilograms. So decigrams into kilograms. So here I have decigrams, you have decigrams here. I want to convert into kilograms. So how many steps am I moving here? I am moving from decigrams. We count how many steps? 1, 2, 3, 4. So it is like we are moving 4 steps. You can see where we have decigrams. 1, 2, 3, 4. In other words, I am moving 1 step, 2 steps, 3, 4 steps. So I'll just say I'll take 435. I divide by this one. I'll assume they are zeros, so I'm moving 1, 2, 3, 4. Then I just put here 1. So if you take 435, you divide by 10,000, it is the same as moving. The decimal is here, you move it backward 4 steps. 1, 2, 3, 4. So this is the same as 0.0435. This is in kg. You'll do the same thing for that. I am moving 800 grams into kilograms. Grams is here. We move how many steps? 1, 2, 3. So this is simply the same as 800. I am dividing by 1,000, and my answer by 2 zeros by 2 zeros. So that this one is the same as moving just 1 step. So 0.8 kg. So that is how you convert units. If you're moving in the opposite direction, the only thing that will change, instead of dividing, you are multiplying. If I pick an example here, if I want to convert maybe a value, I want to convert one of them. I pick this one. Let me pick this value. I want to convert 892 hectogram into maybe grams. 892 hectograms into grams. We look at that. So we want 892 hectograms. We want to convert into grams. So you'll see that this is hectogram. Hectogram is here. I want to convert into grams. So how many steps am I moving? I'm moving from here. It is 1, 2, moving 2 steps. So, and I'm moving downward. If I'm moving downward, I multiply that. So I'll say 892. I multiply with those are 2 zeros or 2 steps. So that is that. And your answer becomes, if you multiply this one, whether using a calc or you do the multiplication, it will be 9892, then 2 zeros. This is grams. So that is how you convert from one unit to another. And all of them, they apply that. If I pick one of them, one of the examples that uses this one, any conversion. For example, we want to convert a number like, we put here line there like that. For example, you want to convert, they tell you to convert maybe 10,000 kilograms. They want you to convert into tons, into tons. Now, this is, you just come and have this example. I'll have here, I'll say that 1 ton, it is the same as 1,000 kg. What about 10,000? 10,000 kg. I'll cross multiply, and you can see it's the same as division. It's the same as 10,000. I'll multiply by 1, then I divide by 1,000. That you'll see the 3 zeros will go with the 3 zeros, so that your answer is 10. You multiply by 1, it will be 10. All over 1, which is simply the same as 10, and this is 10 tons. So even for this, you just have that. Sometimes I say when you're moving from ton to kilogram, this is the same as multiplication. And when you're moving the opposite, it is the same as you are dividing. The same case, when you're moving here, you multiply by 1,000. When you're moving the opposite, you divide by 1,000. The same case, when I'm moving from kilograms to micrograms, I multiply by this huge number here. And when I'm moving the opposite, I divide by the same number. So that is what we have for mass. Quickly, let us go to weight, and I'll open a new page here. The second one, it is weight. And quickly, weight, we don't have much things here. And weight, if I begin by defining what is weight, definition of weight, it is just a pull or force, due to gravity. Is a force due to gravity, and especially this force normally acts on a mass that we have there. So weight is a force due to gravity, and is a force that is acting on a given mass. The SI unit, of measuring weight, because is a force, we will use the same unit of measuring force. And you can guess, what is the unit of measuring force? This is, if you said Newton, then you're right, that the SI unit of measuring weight is Newton, because force is measured in Newton, and therefore even my weight, because it's a force, I'll also measure it in Newton, and the symbol for that will be using N. Well, now that we've mentioned gravity here, gravity is very, very important here because the formula actually for getting weight, we'll have a simple formula here. Weight, I'll be using letter W, is the same as you take the mass of an object, I'll be using M, you multiply by gravity, and gravity I'll be using letter G, so that our weight W is equals to M, you multiply by G. Weight is equals to mass, you multiply by gravity. So this is the formula that we shall be using in conversion. And quickly, I want us to look at a number of examples that is talking about the weight. Sorry for that. So the examples here that talks about the weight is simply again the issue of conversion. So I'll pick one that talks about weight here. I hope you can see one. So here they tell us find the weight of each of the following objects on Earth's surface. Take gravity 9.8. So we want to convert these ones. Here we have 3 tons, we have 52 decagrams, and we have many others here. Now, when I want to do that, if I want to convert to get the weight, we have, they want us to get the weight, and they have said, here, these are examples. They are saying that gravity is equals to 9.8 newtons per kg. Now, this is the same gravity that sometimes we are used to say that gravity is 10 newtons per kg. So it's the same thing. So if they tell you to use 9.8, this actually is more exact compared to this. This one has been rounded off to the nearest whole number. But if they tell you to use 9.8, then that is what you'll have. So if they want us to get the weight that is acting on a mass of, just pick any mass. For example, we have 1 ton, 1 ton. This is the first one, and maybe the second one is 52 decagram. Now, one thing that you should remember, now that gravity is given in kilograms, all the mass that I have here, they need to be converted into kilograms. You cannot apply this formula when you're having here tons and here you have decagrams. So first of all, I need to convert. So I know that 1 ton is the same as 1,000 kg. So this 1,000 kg is what I'm going to use. So here you have 1,000 kg, that is the mass. So I have my mass, which is 123 kilograms. And I apply the formula that weight is equals to mass, you multiply by gravity. So weight is mass is 1,000, you multiply by gravity, which is 9.8. And if you multiply this one right, the answer is supposed to be 9.8, then 2 zeros. This one is measured in newtons. So I have my answer like that. If I come to the second one, this one, they want us to get the weight acting on a mass of 52 decagram. I'll do the same thing. I'll come and say that for 52 decagram, I'll come and convert the same thing. So I'll have, first of all, convert into kilograms. And we know that from this decagram to kilogram, we are moving 2 steps. Simply tells you that 1 kg is simply the same as 2 zeros, so 100 decagram. So what about 52 decagram? This will be how many kilograms? You can see the same as dividing. If you go back to the previous slide, you'll see that you are dividing by 100. So I'll say 52, I divide by 100, so that my answer will be 0.1. 0.52, 0.52, that is kilograms. Now, this is what I need to convert now into weight. And I know that weight is same as mass, you multiply by gravity. I'll come and say that the mass here is 0.52. I multiply by 9.8. So I'll do a quick multiplication here. Just find a space here. You multiply with me and you tell me what is your answer. So here I have 98 multiplied by 52. So this one is 16. Carry 1. 18, 19. Here you have 40. You carry 4 here. Here you have 45. You have 49. That you have 6. You have 9. You have 10. Carry 1. You have 5. I hope that is the correct answer. When you multiply 98 by 52, then you have how many decimals? 1, 2, 3. So I'll say 5.096. You have 1, 2, 3 decimals. They are supposed to be that. So you have that one as the weight that is acting on that. Right. So we have other examples of getting that and how you convert. So you can have more practice on converting mass into weight, but simply we are using this formula. And remember that your unit should be in kilograms. Always convert before you use them on that. And lastly, I want us to talk about density. Right, the last part is density of a substance. And here we have density of a substance, and the symbol for density is rho. We have like that. Let me divide my space. I want to maximize the space that I have here. Okay, density. Density, if I define what is density, density is just mass per unit volume. Density is mass per unit volume. In other words, we are taking mass of a substance. I divide by the volume of that substance. So if I write a formula for that, density symbol for that is that we have the same as mass. Mass we use letter M, and volume I'll be using letter V. So density is the same as mass all over volume. That is the formula that we shall be using. The units, so we have the units of measuring density, units of density, and there are mainly two. We have the two main units, and one of them, now that you're taking mass and volume, you can either have kilograms per unit volume. So this kilograms is for measuring mass, then cubic meters is for volume. That is one of them, but the second one is grams per centimeters cube. And you can say grams is the unit for measuring mass. Then this centimeters cubed is the unit for measuring volume. It's good to know that most of the time grams goes with meters cubed, and grams goes with centimeters cubed. Kilograms goes with meters cubed, like what you have here. Kilograms. The kilograms here goes with centimeters cubed, while the grams go to centimeters cubed. So you might be required in some instances, you convert. If you do not have grams going with meters cubed, you convert the units so that you make them fit like this or like that. So these are the main units that we use in working out density. Also an important NB here, that if I am having units in kilograms per meters cubed, and I want to get them back, I want to get them into grams per centimeters cubed. If I am moving from kilograms to grams per centimeters cubed, here I divide my answer. I divide my answer by 1000. But if I am moving the vice versa, if I am moving from units of grams per centimeters cubed into kilograms per meters cubed, I multiply the question with or the values with 1000. So it is the opposite. This small illustration here, we'll see how this one works out. Right. Let us have a quick examples here. If I pick an example of working out density, let me pick, for example, we have a number of examples here. So express the following in grams per centimeters cubed. So you have a number of examples here, and the vice versa. These ones into this one into you convert into kilograms per meters cubed. So we have this. I'll pick one here, one example here, and another example on this. Then we see how, because the idea that I will use here will be applied to all this, and the same case to this. The concept I will use here to convert into kilograms per meters cubed, it will be the same. So let me pick which any can work. Let me pick, for example, I want to convert maybe 2,700 kilograms per meters cubed into grams. And here I'll pick maybe 450. So I'll pick 2,700. I have an example here. Maybe they want us to convert into grams per centimeters cube. And here you have one example is 2,700 kilograms per meters cubed. So if they want me to convert from kilograms into, they want to convert into grams. So I'm moving from kilograms into grams. We divide by 1000. So I'll come here and say this value, 2,700, I divide by 123, and the two zeros will go with the two zeros, so that I remain with 27 all over 10. This is the same as 2.7. And now this one is grams per centimeters cubed. So in all that, you just do the same thing. I think also I'll pick another one, the same conversion. For example, they want me to have 1.3 kilograms per meters cubed. They want me to convert into grams. I will do the same thing. I'll pick 1.3. I divide by 123. And you see the decimal will move towards my left 4 steps. Let's move 1, 2, 3, 4. That you have 1, 2, 3 in between. You have 3 zeros. So you'll have 0.123. Then you have 1, 3. This one is grams. Let me write the units here, done grams per centimeters cubed. So that is simply what you have. But if they want me to convert into kilograms per meters cubed, I'll do the vice versa. If example one, I pick 450 grams per centimeters cubed. I am moving from grams, I want into kg. So I multiply my answer by 1000. So I'll come and say 450, not my answer. I'll multiply the value here, I multiply by 1 to 1000, so that this will be 450,000. This is kilograms per meters cubed. And the same case, if you have a value like even if it is 1.678 grams per centimeters cubed, I will do the same thing. I'll pick 1.6678. I'll multiply because you're moving from grams into kilograms. I'll multiply by 1,000, so that this will be 1678, 1678, and this will be kilograms per meters cubed. That is how we do the conversion here. So when you're converting in either way, this is simply what you normally do here, converting from kilograms into grams centimeters cubed, and vice versa. Sometimes when I write 1 kilograms, or just let me pick this one, let you not be confused. These units like this can also be written as kilograms per meters cubed. So from the law of indices, they mean the same thing. So whenever they write kilograms, meters, then you have raised to power -3. It just means per from the law of indices. The same case, even for these grams here, they can also write it as grams per centimeters cubed. They simply mean the same thing. These two things, they mean the same thing. Right, let me pick the last example for this. I'll pick this was example 1. Let me pick example 2. If I have an example here, we pick a quick one that is different from this. Go back to the questions, and I pick the density. Pick that. Let me pick, for example, this one. I'll pick any of them. So let me pick, for example, any of them. I can pick even this one. A cylindrical milk churn contains 15 liters of milk. Find the density of the milk in grams per centimeters cubed if the total mass of the milk in the churn is 14 kg. Allow me to do it here. Let me work it here, the space that you have here. So you have a cylindrical milk churn containing 15 liters of milk. Find the density of the milk in grams per centimeters cubed if the total mass of the milk churn is 14 kilograms. Now, if they want me to have the density in grams per centimeters cubed, then I need to look at these units. So these are 15 liters. I can convert them into centimeters cubed because I know that this one is the solution for that. I know that 1 liter is the same as 1,000 centimeters cubed. So what about 15 liters? So this one is you multiply 15 liters. I multiply by 1,000 is the same as 15,000 centimeters cubed. So I have converted 15 liters into centimeters cubed. We have that, and this one becomes our volume. Then we have a mass. Anything measured in kilograms or units of mass then becomes the mass. So I have my mass here, this 14 kilograms. This one becomes my mass. And you see, I need mass to be in grams. So I can convert here. I say that mass here, I know that 1 kg from our conversion is the same as 1,000 grams. So you can go back to the first sessions and you look at how you convert that, and you realize that to convert from kilograms into grams, I multiply by 1,000. So I'll take 14, I multiply by 1,000. This will be the same as 14,000, this one will become my grams. And now I have everything. So this one is my mass in the right units, and the volume we have in the right units. Therefore, density, which is the same as mass all over volume, mass is 14,000, 1, 2, 3, all over 14,000, all over 15,000, 15,000, 1, 2, 3. The three zeros will go with the three zeros. So roughly, you have 14 all over 15 grams per centimeters cubed. So you've converted that. Now, I don't love leaving my answer this way as a fraction. You can't convert this one to see what it will give you in terms of decimals. You can try and convert that one, then you get your answer in grams per centimeters cubed. So get it for in terms of decimal, and well, you can write for me in the inbox. What is your conversion? What is 14 all over 15 into decimal? You divide and give my answer into decimal. I'll be happy to get your feedback on that. So I leave you with this one first, that write this one as a decimal. What is 14 all over 15? You write the answer in the inbox. Well, we have some more examples here. That you can be able to work it out. You look at this one of a different kind. What is the mass? What is the mass of water that can fill? I'm looking at number 2, the cylindrical water tank whose diameter and height are 2.8 and 3 meter respectively. Take the density of water to be in kilograms per liter. Now, this one I didn't mention initially there, but this can also be written in this form. Is only most of the time we express the units of density as kilograms per, this one is kilograms per meters cubed, and grams per centimeters cubed. So if you look at the one that are of different kind, for example, this one, now that this one is grams per meters cubed. If the units here is in capacity, this is liters, I can leave my question that way. So I'll just come, let me try and do number 2. I'll do it here. You have, I need to get the volume, and you know how to get the volume of a cylinder is pi r squared height. You have your cylinder, which is 22 pi 22 all over 7. You multiply by radius. They are telling the diameter is 2.8. So the radius is, you take this one divided by 2. So it will be 1.4 squared. Then you multiply by the height. Height is 3 meters. So get for me this one. Very good. Get for me this one. What is 22 all over 7? You multiply by 1.4 squared. Then you multiply by 2. I need to get your answer there. So work it out. Then you tell me this will be in meters cubed. Okay, so the answer that you have there, you work it out. Let us have an interactive session in the inbox, and we want the mass that can fill that. Given the density of water, I've been given density is equals to 1 kilograms per liter. Now, here it is meters cubed, and this one is liters. So to convert this one, my volume here will be, I will take the answer here, the answer that you have here, I divide by 1,000, 1, 2, 3, because 1 meters cubed is the same as 1,000 the same as 1,000 liters. 1 meters cubed is the same as 1,000 liters. So the answer that you get here, you multiply by 1,000, and your answer will be in liters. So again, now we have my answer here. So the answer that will pick there, put it here, then you multiply by 1,000, you get your answer in liters. So you have our volume now in liters, or capacity. Okay, so if you have that, then you come and you work the last one. They want us to get the mass. Allow me to, you know that mass is given by mass of a substance. From the table, mass will be the same as the density you multiply by the volume. Our density is already here, so I'll take the density of 1. You multiply by the answer that you got here in liters. So you multiply by the answer that you have there. Then you tell me what is your final answer, and it will be your answer here. It will be in kilograms. That is very engaging for us. So let me hear what you have. So tell us what is the answer for this one. You'll just indicate question number 2. Volume is that. Volume in liters is that. Then mass is the density, which is 1. I'll multiply by volume. Very good. Lastly, I want to pick another question that is of different form. So I'll pick a question that is a bit different. Let me pick a question like question number 11. Question number 11. So you have 2,000 centimeters cubed of a mixture consists of 2.5 kilograms of a substance A and 7.5 kilograms of a substance B. Find the density of the mixture. So look at that again, that we have 2,000 centimeters cubed of a mixture contains 2.5 kilograms of substance A and 7.5 kilograms of substance B. Find the density of the mixture. And we have also many more questions that are of the same form. If I pick like this one, we have an alloy. An alloy is a mixture. I just picked a random question. An alloy is a mixture made of mixing by 180 centimeters cubed of iron metal of this density with 120 centimeters cubed of lead, supposed to be metal. Here is supposed to be metal of density that. You calculate the density of the alloy. In other words, the density of the mixture. I will do one here, and the formula here is anytime you're talking about a mixture, density of mixture, density of mixture. Then the density of mixture is normally given by the total mass all over total volume. So you have to get the mass of each item, you add them together, you divide by the volume of each item, you add them together. So if you're talking about substance A and substance B, so I'll take the mass of A, I add the mass of B, I divide by the volume of A, I add by the volume of B. So the answer is what I have there. Let me have an example here, like this one. We have, this is a mixture, an alloy is a mixture made up of 180 centimeters cubed iron and 2,000. So we have 180. So 180 centimeters cubed, then we have 2,000 kilograms per meters cubed. This iron, you're mixing it with 120 and 4 grams of lead metal. 4 grams, 180, and so you're mixing this one with 180 and 4 grams per centimeters cubed. I believe this one is centimeters cubed. So here you have a lead metal. I'm sorry, this one is iron. you have iron here, um, you have iron, a metal known as iron. You're mixing it with the lead, and you want to get the density of the mixture. So when you combine iron plus lead, it's supposed to give you a mixture. So they want us to get the density of the mixture. Now here, be careful, because most of us, they normally take this, if they want the density of the mixture, they take the 2000, they add to 4000 or 4 grams. So that is very wrong. When you are having a density of a mixture, you take the total mass. So we need to get the mass of iron. We add to the mass of lead metal. Then we get the volume of iron. We add the volume of lead metal. Then we add them together. Then we divide. Okay. Now, if you look at this one, 180 centimeters cubed. This is if you are having centimeters cubed, then this one is our volume, and also this one is our volume. So in other words, we are sorted in getting total volume, because total volume, I'll just get the volume of the iron, I add to the volume of uh, lead metal. And I believe, let me do a short correction here. I think it was 120. So here it was 120. So 120 centimeters cubed. So I will add that. Now this one is the density of iron, and this one is density of iron. So whatever we are missing is the mass of iron and the mass of lead metal. So I need to get that. Okay. Here units are a bit different. Let me convert this density into grams per centimeters cubed. And you said when you're converting into grams per centimeters cubed, you divide by 1,000. So if I take 2,000, I divide by 1,000, my density here, density, it will be 2 grams per centimeters cubed. So that I need to have unit the same, centimeters, centimeters, here I have centimeters. And the formula for getting mass is the same as mass of a substance. From the our calculation, mass is the same as you take the density, you multiply by the volume. So if I want to get the mass of iron, I'll come and say the mass is the same as the density, which is 2 grams. I multiply by the volume, which is 180. And my answer here, it is 360 grams. So you have the mass of that. If I want the mass of lead metal, I'll take the density of the lead metal, I multiply by the volume, and the density is 4 grams. I multiply by 120, and what is my answer? This one is 480 grams. So now we have the two of them. So the density of the mixture, density of the mixture here, it is the same as I take the mass, total mass. So mass of the iron, mass is 360 of iron. I'll say 360 plus 480. I take 480 of that. Then I divide by the volume of iron, 180. I add the volume of lead metal, 120. So I want to see what is your answer here. You tell me what do you get. 360, you add 480, you put your answer there. 180 plus 120, you put your answer there. Then you divide to see what you will have. I'll give you a short few minutes for you to divide that. So what is your answer when you take 360, you're adding 480? I believe you got your answer as 840, can confirm. Then what is 180? You add 120. Believe your answer was 300. I believe so. Like that. So that divide the two of them. What is 840? You're dividing by 300. Your answer becomes 2.8. 2.8. Tell me, what do you think should be the units? 2.8. Your units here will be, remember the mass here we've used in grams, and here the volume in centimeters cubed. So it's the density. So I'll say grams per centimeters cubed. This is what I wanted us to really have a quick look at it. That the density of the mixture, it is the mass of individual. You don't get the two of them and you add. So I want you to practice all this. I want you to practice how do you get the density of the mixture. So I will leave a number of questions. I want to leave a number of questions here for you to look at them so that you tell me what are you getting. So I want to leave a number of questions here. Here I have already done for you number 29. I want to do two questions here. I want you to do number 30. So this, I am leaving it for you to do number 30 and also number 32. Number 32. Right, so I want these two questions to be part of your assignment. Number 30 and number 32. Have somewhere to write. Ensure that for clear understanding that you have a place to write these ones. You can stop a video and you write some questions there. You can attempt any other, no problem. Remember, the more you practice on them, the more you get to understand them. You just use the same ideas. Ask yourself what is missing, then find it because you have all the formulas. Then you substitute in the density, the formula of density of the mixture. So I leave this one, and I will also leave, let me pick one from the mass. I'll pick one from the mass here. Okay, this is, I think is also a different question here. Okay, also attempt this one. Mary Bot, you can attempt this one. It's number 4. I think you attempt this one number 4. You attempt that one. So those are around 3 questions, and please have somewhere to write. And the last one, I'll pick one from weight. I pick one from weight. Weight, I think you can have this one number 2. This one to be as part of your assignment. Yes, you get Jen's weight is that one. What is Hamas? And gravity, just use this one, 9.8, unless otherwise. So that you have also a clear understanding. We have another one that has a different gravity, the gravity of the moon. I think also this one will be a good one for you to look at it. So have those questions, write them properly, so that you can see how far you've understood the lesson. Thank you so much for your time.